Today, I'm going to talk about Maths Chapter 8, Mathematical Modeling. What is mathematical modeling? A mathematical model is a mathematical relation that describes the real-world situation. For example, the formula I equal PRT is a relation between simple interest and the other three quantities, that is, the principal, the interest rate, and the time. In mathematical modeling, a real-world problem will be translated into a mathematical problem. We then solve the mathematical problem and interpret its solution in terms of the real-world problem. A mathematical model is a representation of a system or scenario that is used to gain qualitative or quantitative understanding of some real-world problems and to predict future behavior. There are a few important components in mathematical modeling. Number 1, identifying and defining the problems. Number 2, making assumptions and identifying the variables. Number 3, applying mathematics to solve problems. Number 4, verifying and interpreting solutions in the context of the problem. Number 5, refining the mathematical model. Number 6, reporting the findings. Real-world problem. The grocery store, which is far from your house, sells a pack of 10 kg rice at a lower price than the one closer to your house. Is it worth the drive for the cheaper deal? Identifying and defining the problems. The price of a pack of 10 kg rice and the cost of petrol. Determine the distance from the two stores to your house respectively. Find the information needed from the internet. For example, the price of a pack of 10 kg rice from each store, the distance of each store from your house, the current petrol price, the car's petrol consumption rate, and so on. Making assumption. The roof between the house store A and store B is a perfect straight line. Driving car to the stores, purchasing the same number and brand of rice as store A and store B, identifying the variables. Let S equal the distance between store A and store B. P1 equal the price of a pack of 10 kg rice at store A. P2 equal the price of a pack of 10 kg rice at store B. M equal the petrol consumption rate of the car in km per liter. N equal the number of packs of 10 kg rice to be purchased. H equal the current petrol price in Rm per liter. Big S equal the difference in price in Rm for purchasing the pack of 10 kg rice at store B as compared to store A. T equal the difference in the cost of petrol in Rm for driving to store B as compared to store A. Applying mathematics to solve problems. The price of a pack of 10 kg rice in store A is 25 ringgit 95 cents, while the price of a pack of 10 kg rice in store B is 23 ringgit 99 cents. Let the quantity of 10 kg rice to be purchased be 2 packs. So, the price to be paid in store A is 51 ringgit 90 cents, while the price to be paid in store B is only 47 ringgit 98 cents. Therefore, by purchasing the rice at store B, one can save 3 ringgit 92 cents. Let the distance between store A and store B be 6 km. The petrol consumption rate of a car be approximately 17.6 km per liter. The current petrol price be 2 ringgit 8 cents per liter. So the petrol needed for the 6 km route is 0.341 liter. Cost of petrol for the 12 km route is 1 ringgit 42 cents. Therefore, we can save 2 ringgit 50 cents by purchasing 2 packs of 10 kg rice at store B. verifying and interpreting solutions in the context of the problem. The resulting mathematical model is as follows. If S bigger than T, then it is sensible to drive to store B to purchase rice and save more money. If S smaller than T or equal to T, then we should not drive to store B to purchase rice. Since S bigger than T, you can save more money by purchasing rice at store B. Hence, it is sensible to drive to store B. Thus, the mathematical model is able to solve the problem. From the constructed mathematical model, further exploration can be made. If all the variables remain the same, how far can store B be located so that it is an optimum choice? We can find that S smaller than 16.6 km. This means that if the distance between the two stores is less than 16.6 km, then it is sensible to drive to store B to purchase rice. Number 2. What is the maximum price of a pack of 10 kg rice at store B that will attract a person drive to store B to purchase it? We can see that P2 is less than 25 ringgit 24 cents. This means that if the price of a pack of 10 kg rice at store B is less than 25 ringgit 24 cents, then it is worth the trip. Therefore, the above mathematical model allows us to not only answer the question of is it worth it for the given situation, but also allow us to determine other factors that support or oppose the decision to drive further to purchase the rice. Refining the mathematical model. The assumption made regarding the roof between the house, store A and store B is a straight line needs to be revised. If the roof between the three places is not a straight line, how does this impact our model? If new assumptions are being made, then the model needs to be revised to reflect this change. Reporting the findings. Use symbols and diagrams when necessary to report the findings. The symbols and diagrams will depict the whole modeling process until it leads to result. Every model has strengths and weaknesses. What is important is that the model identify those strengths and weaknesses in the report. For example, the value of a person's time is not considered in this model. Is it worth driving an extra 12 km for someone to save 2 ringgit 50 cents? According to this model, saving 5 cents is considered worthwhile. The model did not account for any environmental consideration. Is it environmentally responsible to drive an extra 12 km just to save 2 ringgit 50 cents? This model did not account for environmental efforts such as effort to reduce carbon emission. We have now seen how the mathematical modeling process works by one example as shown above. We should emphasize that we cannot use this example as a template to solve other problems. In solving problems through mathematical modeling, every individual or every group has different ideas, skills, and perception. Open-ended questions such as this may even generate completely different mathematical models which are valid yet result in different answers. Example 1. Jeremy saved 4,000 ringgit at Bank Bunga Raya with a simple interest rate of 1.5% per annum. Jeremy wants to buy a computer worth 4,455 ringgit with his saving. How long does Jeremy need to save? Identify and define the problem. In this problem, we know the principal and the interest rate. The interest from the saving is the amount that Jeremy needs beside the 4,000 ringgit to buy the computer. We need to determine how long Jeremy needs to keep his saving in the bank. Determine the assumption that need to be made and identify the variables in solving the problem. Assumption. We need to assume that the interest rate does not change during the period of our interest calculation. Otherwise, the formula I equal PRT will not be appropriate. We also need to assume that the price of the computer does not change when Jeremy has raised the required amount of money. Variables. The variables involved are I for interest, P for principal, R for interest rate, and T for time in years. Solve real-life problems through mathematical modeling, which involve the following function, which is linear function, quadratic function, and exponential function, and communicate the mathematical modeling process implemented. We can determine the types of functions that may be used as a model for data by studying graph patterns. Linear function is a graph resembles a straight line. Quadratic function is a curved graph in the form of a parabola. The curve may rise and then fall or fall and then rise. Exponential function is a curved graph illustrating an increase or decrease in values of data at a sharp rate. The exponential function can be written in the form of equation y equals CAX, where a is a positive real number, a not equal 1, and c is an initial value. For example, if c equal 1 and a equal 2, graph y equal 2 is shown as the diagram. Example 2. Amin traveled 405 km on 45 liters of petrol in his car. If Amin wishes to go to a place which is 198 km away by car, how much petrol in liters does he need? Solve this problem through mathematical modeling. Identifying and defining the problem. Determine the volume of petrol required for 198 km. We know that the farther we travel, the more petrol we require. Thus, the amount of petrol varies directly with the distance we travel. Making assumptions and identifying the variables. Assume that the driving speed for both 405 km and 198 km routes are the same. Let x represent the distance traveled and y represent the amount of petrol required. Y varies directly with x, hence y equals kx, where k is a constant. Applying mathematics to solve problem. Substitute y equals 45 and x equals 405 into y equals kx. Therefore, y equals 1 over 9x. This equation describes the relation between the amount of petrol required and the distance traveled. When x equals 198, y equals 22 liters. Hence, 22 liters of petrol is required to travel 198 km. Verifying and interpreting solution in the context of the problem. We may not be able to use the linear function model y equals 1 over 9x in all situations. For example, if the 405 km route is through town and city, and the 198 km route is through highway, thus the car will use up petrol at a faster rate in the first route compared to the second route. When this is translated to the real-world situation, the linear function model obtained is not suitable to solve this problem. Refining the mathematical model. In this problem, we are not able to refine the model due to limited information given. Reporting the finding. Report the finding of the problem solving based on the interpretation of solution as shown in the preceding section. That's all for today. Thank you.
This is all of my presentation. Thank you for watching.